Of course. I'm Chacko Daniel. Most of you guys may have heard my talks mainly around the cluster management pieces, best practices for it, and so forth. So I'm a program manager here with Service Fabric, and I've been with the team since almost the inception. So
Really? So you're another long timer.
Very long.
What's your employee number? Do you know it?
Oh dear, I don't.
9, 8, 7?
No, I think from a PM perspective, when I joined, there were only 3 PMs. Yeah, and then I was the 4th one.
Right on.
So I'm sure you would have had interviews with those guys as well sometime.
We
or
will.
a talk, I guess.
I hope so.
Yes. So when I joined, what the state of Service Fabric was very interesting. At that point, we didn't have any management stack. So basically, we just had federation, failover manager. There was no CM. The CM was built.
Interesting.
Right. So we didn't have setup.
Wow.
Things we take for granted. So from there, the journey has been great. We've had like lots of customers on us at this point, right? So including like 1/3 of Azure cores are running on us. So that's super powerful.
Yes.
And it's very, I mean, I'm grateful that I've been with this team for this long, and also feeds my passion for distributed computing. So
Awesome. Well, I mean, you've done amazing work. And the reason I want to talk to you today, and we want to talk to you, because I'm going to bring in some customer questions as well.
absolutely.
Particularly Al, we see you. We're at Service Fabric Mesh, announce it, build. And people should know, you've been kind of spearheading this. I've read your first paper that you wrote with the idea. And I know you're not the only one. Of course, can't work like that in a distributed system. But I wanted to talk to you really about sort of the thinking behind the thinking. So how did we get to Service Fabric Mesh, and what is it? So let's start there.
All right, excellent. So the way, I think I just want to roll back. Like if you look at my blog, which we had posted on the Azure blog. So basically, I did want to go back to 2 years ago or 2.5 years ago at Build when we announced Service Fabric. We were excited about the fact that we could bring the technology which we had, which we're using internally, to the masses, right? So as soon as we do it, we didn't know that managing clusters is going to be not an easy exercise. And so over the course of the years, which we have now felt that yes, most of the customers seem to trip up on that area. Customers want to be focused on applications mainly more than the infrastructure pieces of it, because they won't have PaaS. Platform as a service should be fully managed. So the stepping stones to that is what led to Service Fabric Mesh. And what are the key things which Mesh solves for customers, right? So in addition to making sure that Mesh does support a lot of what Service Fabric can do today and even more, we'll talk about them more later. So the problems it solves basically are customers are no longer responsible for cluster management or capacity management itself. Certainly they're still responsible for application capacity management. They should certainly know what kind of containers do they use, what is the size they need, what is the IOPS it needs, what is the amount of RAM it needs, CPU it needs, and so forth. So those are still a problem in the application space. Anything in the cluster space and the server space, that is when the interesting words like server and serverless and so forth comes into play. So, but anyway, we'll not talk about that a little. Let's go back to your initial question. So the biggest problems we saw over the course of last 2 years was basically I'm having problems scaling up, scaling down. I want auto scale. I want to roll over my certificates, and I'm having problems with it. Although you told me that the primary node type SKUs cannot be changed, I do want to change it because I cannot peek into the future, and stuff like that just came out to be the biggest call generators. At this point, my team actually owns both the services, both the Mesh service and also the Service Fabric service itself, which gives you clusters. So amount of life sites for my extended team worries. I was a big worry. So that's how the papers were written a year and a half ago, and then we started work on this new thing. And we really wanted to get it to a point where it's a fully managed platform as a service. So that's how Mesh was born.
Okay.
And so initially, I'm sure you guys have heard about the code word or project called Seabreeze. So,
Yes.
so it is still, we still interchangeably use this, and that's something which you would hear in the public space as well, because we as engineers just forget once in a while.
Absolutely. And Seabreeze is a really cool name.
Yeah, of course, yeah. I would have loved to have it. So, anyways, the naming is not ours to have. It's there are people who make those decisions. And so we got SF Mesh, and that's the short form of Service Fabric Mesh, and that's what we've got today. So basically, what is Mesh? Mesh basically is an ability for giving a service which we give the customers the ability to focus on the applications and the services and their business, and not be worried about does Azure have capacity? Can I have capacity? And so those things are all gone. So basically, we at the back end host. Maybe we can get to the board sometime.
Yes.
If there's a detailed question, we can certainly answer them. We have clusters, the same Service Fabric clusters, which you used to deploy like 5s, 10s, and maybe hundreds in strength. We have clusters which are thousands of nodes strong. So the reason for that is then at that point, when you say that I want an application with a container which is one core with 20 gigs in it, and I need 100 of them, we are able to give you in seconds. So gone are the days where it takes you half an hour and a coffee before you can get your machines.
Awesome.
So that is our goal. Our goal is to be the fastest. That is my goal. That's where we are driving the team to, and then we are having constant measurements, and we are in private preview for it. Basically, is the fastest way to deploy your applications. See, I keep using the word applications.
Yes.
Because we are still an application platform. And it's just a side effect that we use containers as a way to deploy you. And that is the way to describe what you need. And so that's what is Mesh. So I want to go back to the fact that the two words which you keep hearing from us, from all PMs and all the developers which are who talk to you, and also our blogs, is that we are an application platform. And since Service Fabric Mesh actually is a multi-tenant service, although there will be in the long term, we would have dedicated offerings which basically a customer can say that I don't want to share my node with anyone else, and such offerings are will come. It's in the roadmap.
Okay.
But as of now, every customer who's using us should assume that yes, you would be in a multi-tenant environment, and we would give you the compute isolation and the network isolation. Those are two things which you can guarantee. And so basically, a lot of things which Service Fabric is proud of, we continue to be like it's the most compliant environment out there for a platform as a service offering. So the words like serverless keeps creeping up, and so I know that even in the blog, which I did call it serverless. So serverless does come with some negativeness. Like for example, do I have to worry about cold starts now? So when we talk about serverless, basically we are saying that you don't have to manage your nodes at all. Every other goodness you had, for example, I can actually keep my application deployed and they're warm. We're not going to remove your containers in which your code packages are running just because you're not using it. It's up to you when you want to remove it. So at this point, there are no plans to say just because you're not using the containers that we will actually get rid of it and then bring it back when you ask for it. So at this point, if you ever deploy an application with say four services in it and which has 4 containers, they will be available for you to use instantly once they're up, right? So the problems in the serverless world doesn't apply to us. Okay. So that was the one goodness which was there. So those things still apply. So customers who are wanting to just say, now let's answer your question specifically about, what about I'm a customer, I have a container in ACR or some container repository, and I just want to deploy it. I just don't want to even understand or learn Service Fabric because I don't have a need for it at this point. So they can still do it. Our app model is very, very simple. So yeah, I should not have called it app model. We actually call it the Service Fabric resource model. Okay. And in that, there's a resource called application, and then applications are made of services, and the services have, right? So okay, maybe I should.
It's time for the whiteboard.
Yes, time to do the whiteboard.
Let's go.
Let's do that. So two worlds. So the old world, remember so we'll just not go into the old world. We'll just talk about the new world. Right? So, I mean, like we can be here for hours. So we talked about resource model. Sorry for my handwriting.
Looks actually really good.
So resource model, by definition, what we wanted to change, instead of being very prescriptive on how the hierarchy needs to be and so forth, we wanted to make sure that we talk about resources. Resources are something which you would actually see in the portal or we will be able to manipulate in Azure. And the other golden principle which we had was service fabric offerings can actually be deployed anywhere. So even as SF Mesh, when you think about the resource model, if an application is constructed using resource model, it can be deployed to your existing clusters. You can take it anywhere you want, and also including the cluster you want in Azure. So that was the rule behind, or at least the principle which we still hold true to. But the reverse is not true. Like for example, the existing service model applications, based applications, will need some small changes before it can be deployed to SF Mesh, because one of the key constraints is that every deployment into SF Mesh has to be in a container. So you don't have direct access to, say, for example, your nodes and so forth. So anyway,
but that's important because you're going to have lots of people who are going to try this.
Yes. So it is in our roadmap to give a migration path. It's not that we're going to abandon any of the customers we have today. So we'll certainly...
And also one thing I want to get clear too. Let's say that I want the service fabric of today. This is what I want to deploy into. I want nodes because there's very specific types of code that I want to run on my virtual machine, on my nodes, and I want them to be my virtual machines, and I'm not using containers.
Yep.
Right? We're still going to always support that, correct?
We would absolutely support that. So that is going to...
Just want to get clear.
Yes, absolutely. And then you can actually mix them too. So that's something which we...
Okay.
So that should not be a worry. Just because there's a new service out there that we're just going to abandon the existing customers, that's not going to be the case, because lots of Azure still runs. Lots and lots of Azure still runs with the old model. So it is not an easy turn of the crank. Okay, let's just go migrate ourselves to there. So we understand the pain. We have a lot of tier 1 customers on it. So that will be still supported. So going back to your other question,
yes,
as to why I just want to have deployment containers. So basically, what we'll do is basically, in the simplest form, service fabric resource model basically consists of multiple resources. One is an application, the services. There is network. We can spend some more time on this if needed later, but at a high level, each of these resources are independently defined, and then you can construct them to be an app. Okay. So that is the key. Like for example, if you have a network which in a real world, it is not a very constrained thing that I want a network which is only in my application. Typically, it's possible that you're sharing the network across, and you want to outlive, this network needs to outlive the rest. Mm-hmm. So those are things which you can do. There are definitions. I will not get into the specific syntaxes of these. So we do support the .yaml and .json, right? So those are the two options which you have today.
Great.
Anything which is a .yaml in terms of manifests can be deployed anywhere else, right? So starting from your one box environment where we have Visual Studio integration for it, to the JSON which you would actually deploy to Azure, right? So the reason I went there is to specifically talk about where does containers come into play. So applications are made of services, and the services have code packages. Code packages are nothing but containers, right? So that's how we should think about it. So for any customer who just says, I have a container running somewhere, I have a definition, I want to deploy it, they can write a very simple YAML, point to their containers, and then we will deploy it for them.
Awesome.
Yeah. So at that point, all you're saying is, what is your definition of your container in terms of what the size requirements are and so forth, and also how many do you need? And so to scale up and scale down becomes very easy. You start changing the instance count. So,
okay.
So there are details of all these and documentation. So we'll not spend time on those at this point. But
okay.
So anyway, so that's where we are in terms of where will we take this.
Mm-hmm.
We have, since it's a resource model which actually doesn't have a very tight prescribed way of doing it. We actually can be a little bit more loose in terms of how we do things. Like for example, there is a network. Network will have a gateway. That's something which we can have. This network can just be visible outside or internal only. They're all knobs like that, and then there can be routes, there can be gateways, and so forth. So
Now, speaking of network, starts with an E, Envoy.
ah,
So we are, jumping into that project with the Envoy people, and there, a lot of big companies use it.
yes.
It's a very powerful sort of traffic routing and networking infrastructure, open source. And I just wanted to call that out because I think it's really cool that we're doing this, in
Yes.
addition to rewriting our reverse proxy.
Yes. So basically, Envoy is a great technology which we found, and it's an open source technology. I'm sure you guys have read upon it. Basically, what we are trying to do is we are bringing it to Windows as well. So that is the key, right? So there is a lot of work going on. I'm sure there will be a deep dive with
Sridhar.
with Sridhar, who will talk more about this one.
Yep.
So I don't want to take his thunder away.
Of course.
But the fact is, at the end of the day, what are we going to use Envoy for? We'll use Envoy for things which it's powerful on. Basically, give me routes between my services. And how do I access my services? That actually is the key. So that is what we would do. And so there would be a resource called routes. So that is the tentative name. So don't hold me to it.
Yeah.
So the routes, basically, in the routes you can say, well, I want 20% of my traffic from service A to service B, and the other amount of traffic goes to somewhere else, right? So those are the things. So you can now own your own routes.
Awesome.
So at the end of the day, when you create a tree, when there are tooling around it, you can have service maps. We also use the word service mesh. So those are things which will come.
Great.
So this is building blocks of it, and the fact that we are bringing it to Windows would mean that this SF mesh supports both Windows containers and Linux containers with ease.
Great.
And you bring your own, because containers, that is the biggest value. Like, you bring your own environment. So that actually brings a lot of flexibility. So I always talk about service mesh as being that we don't want to be in the container orchestration war. We want to be in the application and simplification and deployment, and also wanting to go to that direction where we are leading edge in that space. We give you easy programming models. We give you easy application models. This is the one which we have today for SF Mesh. This is the service resource model. So
Yep.
hopefully that answers the Envoy
It
without
does.
taking away too much from Envoy itself. I think we would certainly talk about that.
I hope so.
Yes. The other big thing, one other last one, I'll touch on this because
Great.
you asked me, the initial question was, why SF Mesh?
Yeah.
In addition to the infrastructure pieces which were difficult, the other thing which we've had customers talk to us is interaction with the key vault, managing the certificates, and so forth. Right? So then we will actually have a resource called secrets. That secret will allow you to have a lot of flexibility. One, you can say, "Hey, it's my inline secret. I'm going to give it to you in the YAML and inline. I know it's clear text, but I know you would keep it safely, and I will have it when I show up in my container." So that is one way of doing it. And then another one is to have pointers to key vault. Like if you're deploying this to Azure, you have pointers to the key vault. That's where you manage all your certificates, and it magically shows up in my container. So
Awesome.
that is coming, and that's another big hour. So I will not touch on that.
Rakshita,
Yes.
for example, is working on that. She's right behind me.
Yes.
I talked
yes.
to her and watched her, listened to her. So,
So
amazing
that-
dev.
Yeah, absolutely. So these are, whenever small words like secrets have a big service behind it. So I will touch on a lot of things which we have improved on from my days when I started off about 10 years ago, right? So we reached a point where we truly believe that we have a service which would actually lead us into great success, and also to make sure that the customers who are on the sidelines thinking that, oh, it's very difficult to, now there is no friction. Anyone who has a container can come to us. They don't have to adopt our programming models. When I use the word programming models, basically are the models which we have today, for example, as actors and reliable collections. There are some equivalents for SF Mesh.
There are.
Yes, so that's coming. So,
Okay.
I
That's
know.
the question from Al.
Oh, yes, okay.
So he
Alan
wants
has a
to
question.
know about, for example, one of the cool things about reliable collections and the way that we manage state and statefulness in our world is that we guarantee by design really low latency. Because the state is present and co-located near your compute on a node. And we replicate that across your ring.
Yes.
So the question is, what about that's and service fabric, mesh, and that world? That's really Al's question.
All right. So I think I want to step back a little bit and give you a little more context. Right? So making containers stateful is a challenge.
Okay.
Like that's a challenge which every orchestrator has. So the solution has been at this point to have disks attached, volumes attached to them. So yes, of course, we actually do. I don't know whether there was a demo we gave about that with the stateful containers which we deployed. So basically so there is also volumes, right? So there is another resource which you can attach to your container. Which basically talks the two kinds, of course. So one is you can use Azure Storage as one of as a volume driver, and then use that to get your container more stateful. That means if it fails over, I still have not lost my state. So you asked me the second question, saying, hey, that was great. I still don't have a good way to make sure that what is SF doing in that space. So
yes.
One is we're giving you a volume driver as well. So if you look, I don't know whether you spoke to Raja.
No, not yet. He's hard to get. I will try.
Maybe get Gaurav. So they are working on something very simple way of making your containers stateful. So it's called SF volumes, and you can choose certain set sizes. It's like attaching a disk. It's like I don't want to use word micro disk. I mean that comes to mind. To your container, and you're just writing into it, and it fails over. You wake up somewhere else. It's there.
Awesome.
So that is coming, and then the other question you had was basically talking about the programming model side of it, right? So two program models we have today are actors and reliable collections.
Yep.
So the reliable collections pieces of it, which gives you the reliable queue and reliable dictionaries and in-memory artifacts, if you will. So those are also on those are the basics on which these SF volume is built. So that piece is also will be exposed to customers who so need it.
Okay.
So I know that there are customers who have a need for that, so that's going to come as well. So pretty excited about where we're going. Right? So none of what Service Fabric was about changed. The only things which we took away are the things which customers did not care too much about, basically owning their own infrastructure and trying to manage it.
Got it.
So for customers who actually have a compliance need for it, of course I have not forgotten about them, we would actually have some offerings, like for example I was talking to you earlier, where you would have an ability to say, well, no, although you are a multi-tenant service, I don't want anyone to be on my machine. So those are things which will come. So that is mesh.
That's great. So now that in Service Fabric Mesh, we're in container world, right? And so now you have a series of containers.
Okay.
How does that work in terms of the underlying system services and how they manage that world?
All right, so I think, maybe I will draw another diagram for you.
Great.
So let's just go a little bit more here. So in the Service Fabric world, remember we used to have clusters. This is something which we had called clusters. And the clusters were typically made of 5, 10, 100 machines. And this is something which you owned. So, and each of these are 1, 2, n. So this n used to be typically, I've not seen more than 1,000 node or higher from a customer perspective. Although remember we had done this demo of 1 million containers.
Yeah.
So that n was 3,500 or something of that nature. So that was a large thing.
Yeah.
So what we are doing in a multi-tenant scenario is this n would be nearing 5,000 or something of that nature. So and when a customer gives you the payload onto this, we give you two things as talked about. Basically, there is compute isolation and network isolation. And then I'll talk about that a little bit. So from a capacity perspective, SF Mesh, which is our Mesh RP, this is the resource provider, that is the resource provider you talk to, has a multiple pools of these clusters. Say, for example, this may be a very stupid example, but it's just to highlight the point. So a cluster, you could choose to say this, in this cluster basically is a Gen 5 and Gen 5 cluster, and then the next one basically is, forget the word Gen 5, this happens to be a class of machines, and then the other one could be a GPU SKU.
Okay.
So if a customer says, I want to be in the GPU, I have a need for a container which actually has to be on a GPU, then we will place it there. So your question may be that, well, how the heck did RP decide?
Yes.
That is where it's going to be. So I will give you a little peek into the RP, and I'm sure you will also talk to Vaishnav, so I will not take away all the details behind it.
Absolutely.
Right? So this is, we'll call it SF Mesh RP. The RP itself has multiple pieces in it. So one is, the very lowest level is, we'll call it the inventory manager. Inventory manager, as the name suggests, happens to talk about what is my inventory of machines which are out there. What kind of application, what kind of clusters do I have? How much of it is left? Do I need to have more? So forth. So that guy is like a human. I manage inventory.
Got it.
Right? So then there is another, there are a lot of other services. I'll just only talk about the ones which, so then the other one is the cluster allocator. And then there is the top thing is basically there is another service which takes in the input from the customer. Right? So basically this is the model. Basically the model which we talked about here gets in. And then I will not talk about each of these, of course, has a gateway, there's a partition manager, all that stuff, which like any other application, Service Fabric RP also is an application which has multiple services.
Got it.
So it is built on Service Fabric too. So it's not that we consume ourselves. So that's what it is.
Right on.
So cluster allocator's job basically is saying, okay, I have a request which came in which asks for say 10 CPU, say 10 containers. Each container asks for 5 CPUs, and then say 20 gigs each.
Okay.
So it needs to find from the inventory manager, oh, okay, tell me which one, based on which one do I allocate to? I have this need. So this guy is always ready. If it is not ready, we have not done a great job. Right? So so far, it'll find oh, okay, I think this pool A, is the right place for you, and we'll put you there.
Great.
So that's what happens. So that is cluster allocator. The simple thing about cluster allocator is think about resource governance and the placement constraints and so forth that Service Fabric provides. A lot of that sauce is used here. So things which we have the customers use is exactly what we're using here. So now the second question I'm sure people are now asking about is, okay, does SFR, Service Mesh RP, go and deploy these clusters? So like inventory manager, how does the inventory manager work?
Yes.
So this guy, when it says there is a threshold, there is of course a config which talks about thresholds, saying, well, if my pool is running 60-80% utilized, I want to go create more. So that the customer doesn't have to wait 30 minutes for something they ask. It should be in seconds. We take that overhead. And we, of course, talk to the other RP, our SFRP. So this one is the one which, this basically, SFRP is the current service which we have, which allocates clusters. So it knows what to do. So basically, we'll send a request for more nodes, a new cluster, whatever have you, and then that shows up for the cluster manager.
So Service Fabric Resource Provider, that's what it stands for.
Yeah,
Okay.
and this is the guy who allocates clusters.
Nice.
So hopefully that shows at a high level as to how the innards of what will work. We'll just get into it later.
Great.
But the great thing about this one is we are reusing what we already have in terms of who gives you the clusters, how do you patch your clusters. All those things are the same things which a customer has today. So a lot of your questions were, what happens to my existing offering?
Yes.
An existing offering is what is used for the new offering. So yes, in the long run, maybe we will merge them, do something like that for efficiency's sake, but the raw technology still exists.
Awesome. This is great.
Okay.
It's really awesome. And I think, you've answered a lot of questions. And so one specific one for the people that are actually in the private preview. We have the private preview 3 is now in the works. We're not announcing anything.
Yes, okay.
But it's in the works, yes?
Yes, it is.
Okay.
Yes. So we've been in private preview for over two or 3 months now for SF Mesh. Even before announcing that we have close to 500 customers who are using it. So that's one of the reasons why when there was a demo, we were sort of confident that yes, it will work. We did a live demo. You saw the bouncing pyramids change. Like if we had to upgrade on the fly, it happened, right? So
yes.
That's why we were able to do it. So basically, we have great feedback from the customers. And then the preview is open for people to sign up, of course. So I'll write the URL for you guys.
Perfect.
So https aka.ms sf mesh preview.
Okay. And this, of course, will be in the description of this video.
Yeah. So do sign up. So what will be interesting is if there are scenarios where you believe that you actually can start to use this technology like right away, and then want to give us more feedback and influence certain areas which you're passionate about, certainly put that as a follow-up question if possible. So anyway, so that's what is the place to sign up. So we have customers who've been using it private. We are in private preview 2. We're ready. We're working on private preview 3. Private preview 3. What is so vital about it? Basically, that has a lot of app model changes which we want. We want to also stabilize this. This is a new service. Like all your applications, we also are. This is just an application, so there are rough edges. So private preview 3, we believe, is the one which will solve this for us. And private preview 3 is based on 2 things. One, it is Service Fabric 6.3, which is our next release. So we would actually use that. So that is the same version you guys will be getting, and Mesh will certainly use it. The other thing which will happen also is there will be Visual Studio tooling which will come with it. So we will actually have an SDK which will have the ability to create new projects and use this new resource model, and also the other old one. So this, of course, will be in preview. So that's coming. So I'm pretty excited about it. And
awesome.
So that's coming. And I would say, I can't give you the date out, but pretty soon.
Awesome. Well, hey, congratulations. I mean, I know it's been a long journey from when the idea was first seeded.
Yes.
Right? Hey, why don't we make it easier for people just to throw their application up there? Right? We already do all this infrastructure and all the complexity and shield them from that, but they still have a little bit they have to deal with.
Yep.
So now we're there.
Yes, we're there.
In preview.
We're in preview, and we want to get to public preview pretty soon.
Yep.
The only constraints in the public preview would be how much of capacity can you use, right? So public preview, for the most part, at this point, I don't know when we will start to bill you. So maybe I should cover that in a few seconds and then I'll stop. So
sure.
So you're paying only for what you deploy. Like for example, when you deploy a container with 1 CPU and 20 gigs of memory, you will actually get charged only for that.
Okay.
You do not get charged for anything else because that is all you're using. So whatever resources you consume, you get charged for it, and then you can turn it off. You can actually delete them, and then come back.
Okay.
Like for example, if you are using a volume driver, which actually was an Azure storage, so that outlives a lot of your applications because it is in Azure storage. So this is an example of things which can be utilized, and so you just pay for that one.
Got it.
So most of what we do would be about per second billing.
Per second, okay.
Per second. And you might ask the second question, hey, what if, is the cost of containers going to be higher somewhere or same? Cost of the containers are going to be same across in Azure.
Okay.
So whether you use AKS, ACS, or Mesh, if you get a container from Azure, it's going to be the same price.
Right on.
Thank you.
Take care.
Yep.
Nice to meet you.